slow touch, brown and white. Like I go country, grab and buy. We can go bust, eye for eye. We can lose trust. White rum, fizzy pop. Where you they go, we they go up. Catch my vibe, let me go off. Blam the trash, man it's so tough.
Alright yo, put the belly on the body, make a clutch. Seen her watch, now she wanna give crutch. Boy got peas, now she hopping in the pod. Man a real life, sugar gal and my forget what. When she want dark, told her meet me at the top. Switching lanes the other day, I seen her waiting for a bus. Maybe this a Moncler sweater, diesel denim. Buy another one, my pockets fat like heather. Neck froze like I don't know no better. Benzo truck, white seats and they leather.
Hello, we are from Group 1. So today, our topic is Vapor-Liquid Equilibrium, or also known as VLE, in food processes. The timeline always works well, so here how it goes. First, we're gonna introduce you on what is VLE. Next, we're gonna take a look at the application of VLE in food processing. Next, we're gonna take a look at the importance of it, and last but not least, the conclusion. So, what is VLE? VLE is the state of coexistence of liquid and vapor phases. In thermodynamics, VLE describes the distribution of a chemical species between the vapor phase and a liquid phase. Vapor-liquid equilibrium. The processes, such as in distillation, adsorption, and stripping, are characterized by the contact between two phases, which are liquid and vapor, initially in non-equilibrium condition, and aim for after the contact, the separation or isolation of certain components. The transference of substances from one phase to another is performed until the equilibrium state is reached, which is the limit condition. In the equilibrium condition, the compositions in each phase are generally different from each other except for azeotrope system. The difference in composition makes it possible to separate a particular compound from the original mixture. So, we're going to proceed with the application of VLE in food processing.
Now, we move on to the next part, which is the application of VLE in food industry. There are a lot of industry in food processing that apply vapor-liquid equilibrium in their processing line. For example, is juice industry. As juice are multi-component mixtures containing water as the main substance, the existence of hydrogen bond from water molecules provide strong interaction with solutes, affecting the mobility of water in the solution. This is where two distinct sectors of the industry require information on phase equilibrium, which is in the concentration of juices and in the recovery of volatile compound. The concentration of juice and pulps is done by evaporation conducted at atmosphere boiling temperature of product, where the calculation are performed at VLE condition. In parallel to the concentration of juice, volatile compounds are removed naturally during the processing. These mixtures of volatile flavoring of juices is commonly used in food industry, and its recovery brings an economic gain in industry.
Now I will be presenting about the application of VLE in food industry. First, vegetable oil industry. Vegetable oils are composed of mono, di, and tax-free fatty acid and other minor constituents. Next is the process of vegetable oil. First, the removal of solvent from the miscela. Second, the refining step through the deodorizing oil in the distillation of fatty acids. Third, the fractionation of fatty alcohols. Fourth, the production and purification of glycerides. So, where is the VLE applied in this industry. First is the distillation process, the recovery of co-products from the oil such as the vitamin E, omega-3, omega-6, carotenoids and carboxylic acids involved in the separation steps. Second is the purification process. VLE is applied in this process in order to promote improvement and to avoid losses of high value added compounds. So these two processes are involved where the VLE is applied to. So for the conclusion is the application of VLE is shown as a key point in the decision making of operational conditions in the food industry.
Okay, there is the importance of VLE in food processing. Hello, welcome to the video. Okay, there is a lot of example of the use of VLE that is not in food processing industry, such as example the use of distillation in the production of essential oils. This is the equipment. Next, the use of distillation in the production of distilled water, and this is the equipment used. So next, the example of the use of method of vapor liquid equilibrium in food industry, that is jellies, production of biscuits, and the production of concentrated juices. Why I'm saying jellies and concentrated juices also included in vapor liquid equilibrium method? Because let's see the explanation. Okay, look at this explanation. In food processing, the use of VLE is not only related to the unit operations of separation. VLE is important in food preservation also, such as jellies, hydrated fruits, and cured meat. That's why when I say concentrated juices and jellies before, also related in the production is related with vapor liquid production. Because it used the same principle, which is low presence of free water in food, in jellies, in fruits, in meats. Another example is for whiskey. The use of VLE principle in distillation of whiskey, because to study the phase VLE, vapor liquid equilibrium. So we can predict the condition of separation of ethyl lactate in whiskey. Next, VLE are also important in different steps of processing, such as encapsulating compounds. For example, I think maybe we use this in what we call it, encapsulate the medicine in pharmaceutical industry, also food industry, because we know that when it comes consumed by human, so it is equal to food. Next, in aeration and deaeration food processing, VLE are also important in oxygen absorption during aerobic fermentation. This is maybe when we want to produce a wine, we use fermentation, we need VLE principle also in produce wine. And then in the aeration of liquid foods, and in absorption of or stripping of carbon dioxide. Maybe we use this when we produce the carbonate drinks, because we use carbon dioxide to produce it. And then next, the last one is VLE also important in order to calculate the shelf life of food product. Okay, this one maybe when we say food and shelf life, when what we call that, we can calculate the time when it's supposed to spoil, so that the consumer were aware that they cannot consume when the product is spoiled. So that we use the VLE principle also to calculate the shelf life, so that we know, we can notice when the spoiled food can be occur, so that we can block it from being marketed to the consumer. That is also the very important the use of VLE principles in food industry. I think that's it for the importance.
To sum up our presentation, the application of VLE is shown as a key point in the decision-making of operational conditions in the food industry such to obtain the desired products and to maintain the required quality. VLE is important in the different steps of processing, as in drying processing, in the encapsulating of compound, in the aeration and de-aeration of food, and such else. The operational control of such steps requires equilibrium data so that products can be obtained with the characteristic desired by the consumer, industry, and legislation. Therefore, reliable data on the equilibrium are fundamental in the formulation, processing, and quality control of the food products for food industry. That's all from us. Thank you.